each of these problems, we need to fill in this whole table of stuff. And the reason it's like this is so that you see the different connections between things. I'm going to go through a few bulleted points here. So a quadratic equation can be written in three forms: standard form, factored form, and vertex form. And I have a column for each form. The graph of a quadratic equation is called a parabola. If you didn't know that, you gotta know that. The vertex of the parabola is the lowest or the highest point. So you have this U shape, right? And the vertex is going to be, in this case, the lowest point of that U shape, which we call the minimum. If it's an upside down U shape, it'll be called the maximum. The X intercepts of the parabola are the points where the parabola intersects the x-axis. You can find the X intercepts. There's a little. Oh, this is good. You can find the X intercepts by setting y equal to 0. That's going to be key for us. Y-intercept is where your parabola crosses the y-axis. There's only one, and there's a typo here that should say y-intercept instead of x-intercepts there. So the y-intercept of the graph, you can find that by setting x equal to 0 and solve for y. God bless you. The line of symmetry we'll talk about. It's also known as the axis of symmetry. Is a vertical line that divides a parabola into two congruent halves. And equations of vertical lines are all in the form x equals. And so we're gonna let's use that in this first problem. Bless you. So how did I say to find the y-intercept? Set x equal to 0. So here's my equation. If I set x equal to 0 for my y-intercept, I get 0 squared plus 6 times 0 plus 8. What's that equal to? 8. Because this is 0, that's 0. All we get is y equals 8. And so our y-intercept is going to be a point. 0 is our x value, and 8 is the y value we got. So that's one thing. If you have standard form, it's easy to go to factored form. Just need to factor. So I'm going to rewrite my standard form here and try to factor it. So we're looking for two numbers that multiply to 8 and add to 6. What are they? 4 and 2. And we have a lot of background with factoring, so hopefully you're getting more comfortable with this. If not, here's another opportunity. And then factor by grouping. And you finally get it into the form that we want. X plus 4 times x plus 2. And if you got x plus 2 times x plus 4, that'd be the same thing, right? Your factors can move around. So we have factor form, we have our y-intercept. If it's in factored form, the power of factored form is to get your x-intercepts. Because how do you find x-intercepts? Set y equal to 0 and solve for x. And if it's already factored for us, I get 0 is x plus 4 times x plus 2. How do you solve for x? Set each factor equal to 0. This is what we have been doing when we're solving with the circle problems and other problems that we've done. And we get x is -4 and -2. So we got two x-intercepts. X-intercepts are points. They have x coordinates and y coordinates. So one of the points is going to be -4, 0, because y is 0. And the second point is going to be -2, 0. All right, so now we already have 3 points for this graph. Let's see here. Vertex form we don't know about yet. We're going to learn. That's going to be a new thing for us. We're going to learn about. We have an idea what a vertex is. So we're going to skip over that and see what else we can get here. Let's start looking at the graph and start with our x-intercepts. So we have our x and y axis here. We have an x-intercept at -2. and at -4. And a parabola has symmetry, meaning it has a middle, and everything to the right of the middle reflects everything to the left of the middle. And so if I have my two x-intercepts, I know where the middle is. The middle is going to be right in between them, which is at what number? -3. And so the axis of symmetry is this vertical line that kind of cuts right down the middle. And all vertical lines are in the form x equals some whatever that x value is, in this case, -3. So x equals -3 is the equation of that vertical line called the axis of symmetry. Your vertex is going to sit on that axis of symmetry. And so when I'm finding the vertex, I know the x value for the vertex is going to be the same always as the x value in the axis of symmetry, because the vertex is in the middle and the axis of symmetry is in the middle. And by knowing that, I can, if you know an x value, you can always find a y value by taking that and plugging it into an equation. It's your pick. We can plug -3 into the factored form, or we can plug -3 into the standard form, and we'll get the same y value. So I'm going to do that. So what do you want, standard form or factored form? And it's probably, as you're working through these, it's probably safer to use the form that was given to you, because you know there's no errors in it, right? Like if you factored in, there's a possibility that you made an error. So if you use the form that was given to you, there's less likely that you're going to have an error there. So I'm going to take my standard form y equals, I'll plug a -3 in. Have fun today. 6 times -3 plus 8. And follow order of operations. We get 9 minus 18 plus 8, which is -1. So that's my vertex right there. So I can plot that point, -3, -1. So from 0, 0, I'm going left 3, down 1 for my vertex. We also have our Y-intercept, which was 0, 8. I'm going to plot that. And if you know where the middle is, whenever you find a point on one side, you automatically get a point on the other side for free. So I know there's a point that reflects, if I take that Y-intercept, there's a reflection on the left side. Where would that be? So go from the middle. How far from the middle is the y-axis? 3. So I need to go 3 to the left of the middle, and I end up at -6. And same height, so 8. So there's a point right here at -6, 8, that we know has got to be there because of the nature of symmetry. And so here, I'm going to ask that you, whenever you graph, you use 5 points. And at first, these will be the 5 points we're going to use. We can fill those points in our table. So the middle of our graph is the vertex at -3, -1. Furthest left is -6, 8. We have the x-intercept at -4, 0, -2, 0, and our y-intercept at 0, 8. Okay. For our vertex, I think I wrote it for you. Let's see here. We go to the notes on the second page, right here, on the third point that I'm making. There's a relationship between the vertex and the vertex form. If the vertex of the parabola is hk, then the equation is going to be a times x minus h squared plus k. the lead coefficient A will be the same for both standard form and vertex form. So that's going to be something new, and I'm going to show you what that means in terms of this problem that we're working with. So there, I'm just showing you where it is in the notes, so you can go back to that. So our vertex is in this form HK. We know H is -3, we know K is -1, and we can use that to get our vertex form of the equation. And also, if you go back and look, it says the A here is going to always match the A here. Okay, and so we can look and say, well, what number is in front of x squared over here? The 1. And so we're going to have a 1 in front of the parentheses there. And usually we don't write the 1, but I'm going to write it this time just to emphasize A's 1 in this case. Okay, and then we have x minus h. H comes from the first value in our vertex. But notice positive h is -3. So what would negative h be? Positive 3. So I'm going to put an x plus h here. Sorry, x plus 3 here. So this minus h right here, it doesn't mean put a minus sign. It just means use the opposite of whatever h is. So if h is negative, you're going to put a positive there. If h is positive, you're going to put a negative there. I don't know. I was saying 3, I guess, and I wrote a 3. Should be squared. And then k is going to be the -1, so I'm putting -1. And so for right now, that's how we're going to know the relationship between our vertex and our vertex form to get that vertex form. Okay. So we have our vertex form. We have our factored form. We have a lot here already. All we haven't filled out is our domain, our range, our increasing, and our decreasing. And again, these are maybe new things for you, may not be. But just to show you where they are in the notes, it'd be on the second page on the bottom. The domain is the set of x values for which a function is defined. The domain of a quadratic equation is all real numbers. So that's important for us. So whenever you're dealing with quadratics, and that's what our unit's on, we're allowed to plug in anything. So that if I ever ask you for the domain, you're always going to say all real numbers for quadratics. When quadratics are used to model real-world problems, okay, this is where the domain can change. Because sometimes in real-world problems, it doesn't make sense to talk about negatives. And we'll get to real-world problems probably on day 9 or day 8, so in a while, okay? But for right now, before we get to like real-world problems, you're going to say all real numbers. The range of a function is a set of y values that result from the domain. We'll talk about that. But the key thing here is to know that range goes with y value. Okay. Also, the next thing, we see that a graph increases or decreases by tracing it from left to right, just like you would read a book, from left to right. And if your hand's dropping, it's decreasing. If your hand's rising, it's increasing. Okay. Thank you. And the axis of symmetry divides the parabola into 2 halves. One half will always be decreasing, the other half will always be increasing. And so let's look at what we have here. So what's our domain? What does it say in the notes? All real numbers. Because the domain, again, is what am I allowed to plug in for x? Answer, anything you want. Okay. Now, after I plug in something for x, what could I get back? What y values can I get? And you can't get everything, and you see that in the graph. Look at the y values. Is there anything down here in terms of a graph? No. What's the lowest y value I can get? -1. I can't get anything lower than -1. Can I get everything above -1? Yes. That's what the graph's showing us. The parabola continues to increase. It's got the arrows pointed up. So, thank you. So for the range, so domain is x. I'm just going to put x here to remind you. Domain's x values. Range is for y values. And so we're going to say all y values greater than or equal to -1. And it's important that you say equal, because that negative one's part of that, right? That's at your vertex. Increasing, so half of your graph will be increasing, half will be decreasing, and it's split by your axis of symmetry. So as I trace from left to right, first I'm dropping to the bottom, so it's decreasing. And so this would be decreasing on the left side, and it's increasing on the right side. And when we talk about increasing and decreasing, we're actually going to give it in terms of x, not y. So what x values talk about the right side? From where to where? X greater than what? -3. So you're always going to use this value here. This is your axis of symmetry. This is the middle, right? And so if I want to talk about the right side, I'm going to say everything bigger than the right, that -3. If I want the left side, everything less than that. And so x less than -3 would be the decreasing part. Okay. So as you're filling these out and doing these problems, make sure you have all three forms. Make sure you have your intercepts, your vertex, your axis of symmetry, your graph, domain, range, increasing, decreasing, and your table. A lot of pieces, I know, but it's important that they're all together so you see how they're all connected and they're related to each other. Okay. Number 2, I'm going to leave for you to do for the homework. Let's look at 3 and 4. Let's do 3 together. It's the same setup, except you start with something different. I don't give you standard form. I give you vertex form. And you got to work from vertex form and find all the pieces now. What do you think is easiest to find when it's in vertex form? What's that? Any guesses? Maybe the vertex. Vertex form, vertex, right? So vertex, remember, is HK. So what's H? Remember, it's opposite of what's there? Negative H is 2. So positive H is -2. And K would be -9. Okay? The vertex is directly related to what? Line of symmetry, the middle. Right? Because the vertex is always in the middle. And so if you know the vertex, you know the line of symmetry. It's what? -2. But if you just put -2, that's not a line. That's a number. You gotta say x equals to get the line. That's a vertical line. Okay? So we have that. I'll start to draw what we're having here. So -2 is the middle, so I'm shifting everything a little bit to the right. And -2, -9. So vertex is way down there. And here's our middle. All right. That's about as much as we can do from vertex form. So we need to get it into other forms. And if you have vertex form, the easiest form to go to after vertex form is standard form. It's harder to go from vertex form to factored form. So you're going to want to go from vertex to standard. And the way you go to standard is you just multiply it all out, simplify it. So I'm going to start with vertex form here. And start to multiply it out. This x plus 2 squared means x plus 2 times x plus 2. And then I got a -9 tagged on at the end. Be careful when you multiply out that you follow order of operations. You have to do all the multiplying first, and then at the very end, subtract 9. Don't subtract 9 kind of midway through. It'll throw your answer off. So distribute get x squared plus 2x plus 2x plus 4 minus 9. And now you can use that 9 after everything's distributed. So simplify at combined like terms, you get x squared plus 4x minus 5. That is your standard form. Y-intercept we can find? What is it? Okay, but what is it? What's the answer? -5. Like you see the y-intercept in standard form. I don't know if you noticed, but when it's in standard form and you plug 0 in, all the x values will go away, and you'll just be your constant will always be that y-intercept in standard form. So that's why I have it lined up there. Could you find your y-intercept in vertex form? You could find it in any form. You just plug in 0 for x and solve, and you'll always get the same thing if it's the same problem. So like if I check it here, if I plug in 0 for x, I get 2 squared, which is 4, minus 9, which is -5. Over here, if I plug in 0, I get 0 squared plus 4 times 0 minus 5. Everything zeroes out except for the -5. So no matter where you're going from, your y-intercept is pretty easy to find. You just plug in 0 for x, and you get your y value. Once you have standard form, you can get factored form by factoring. So we're looking for two numbers that multiply to -5 and add to 4. -4, -1. So we split this middle up. Actually, that's not going to work. -4 plus -1 is not 4. 5 and -1 would work. So x squared plus 5x minus 1x minus 5. Factor out an x. Factor out an x plus 5. And you get y is x plus 5 times x minus 1. And that is our factored form for this quadratic. What's easiest to find when you have factored form? Lined up. I lined it up for you. Factored form lines up with X intercepts. But I don't have X intercepts here. I have roots. That's because they're the same thing. And I need you to see that. X intercepts, there's 3 synonymous names here. You got the X intercepts, you got roots, and if you look further, you'll see zeros. All 3 of those mean the same thing. And I just want you to get used to the verbiage. So that's why I'm doing that for you. Okay. So find our roots, which is the same thing as finding our X intercepts by plugging in 0 for Y and solving for X. We get x plus 5 is 0, and x minus 1 is 0. So x is -5 and +1. So now we got plenty of points to finish our graph off. So let's start graphing. So 1, 0, -5, 0. And you can check those x-intercepts should both be the same distance from the middle. And they are. They're both the distance of 3 from the middle to the left and to the right. We have our y-intercept, which is at 0, -5. There. And when you get that one, you get one for free on the other side. Where would that be? -4, -5. And then we can sketch our graph. Make sure it doesn't look like a V. Make sure it looks more like a U. Okay, it needs to be curved, not to a point. Okay. Put all 5 of our points in our table. Bless you. And then domain is going to be all real numbers. Range. The domain is always your X, right? Range is Y. So what would you put for Y? Y is greater than or equal to -9. Increasing and decreasing deal at the left and right side of your axis of symmetry. So -2 is going to be the key number we're going to work with. We're going to say it's bigger than or less than -2. And so where is it increasing, on the left or the right? It's increasing on the right side in this one. And so we'd say x is greater than -2. It's decreasing on the left side. So we say x is less than -2 for decreasing. And now we've hit all the pieces of information that we need to hit. Any questions on all of that? I know it's a lot of little pieces there. I'm okay with that. You can do that as well. So 4, I'm going to leave for you to do for homework. Just look at the third page. And I'll do 6 with you on that one. Why don't you get a head start though on 6? See what you can do in 6, and then I'll catch up to you. Guys, there's a fix on here. I wrote my middle point wrong on that table. It should be -2, -9. 0. So what are you trying first on this one? Finding the vertex. Anybody get the vertex? +1 and +4. Good. Right? Very good. Anything else that you guys got? Okay, you went and found the Y-intercept. You plugged in 0 into the vertex form. We can do that. And if I do that, I get -0 minus 1 squared plus 4. It's just a little trickier here. You can do it. Just need to be careful with order of operations. So I'd have to square what's in parentheses first. And I get +1 inside the parentheses. And then I need to distribute the negative to the 1. And then you should end up with +3. Did you get that? Okay, so you gotta be careful if you're using that. So you can get the Y-intercept from this, but it's just a little more complicated. If you put it into standard form first, then it's really easy to see. Anybody try putting in standard form yet? Okay. Did you get Did you get +3? Oh, okay. Still working on it. And it's a little complicated getting into standard form because of that negative. And so I just, I'll work through that with you. So you get y is negative x minus 1 squared plus 4. And that negative out in front, you keep that out in front until you're done squaring. You have to square first because order of operations is exponents first, then multiplication, right? And so it's going to look like this. You're going to have a negative, and then in parentheses, you're always going to keep parentheses there until you're done with your x minus 1 times x minus 1. So on the next step, negative, still parentheses. When I distribute, I'm going to put everything I distribute in the parentheses, but I'm going to leave the plus 4 out of the parentheses. So it'll look like this. X squared minus x plus 1, close parentheses, plus 4 at the end. Got to do that. Otherwise, it'll throw your whole answer off. I'm going to simplify what's in my parentheses at this point. And then you can get rid of the parentheses once you distribute the negative to everything in the parentheses. So y is negative x squared, positive 2x, negative 1, positive 4. And then you can add the negative 1 and positive 4, and you finally get y is negative x squared plus 2x plus 3. And we see our y-intercepts are going to end up being 3. So y-intercept is 0, 3. Standard form we have there. Anybody get the axis of symmetry? That's an easy one once you have the vertex. 1 is not an axis of symmetry, it's a number. X equals 1 is what I'm looking for. Good. We need to factor eventually, so y equals negative x squared plus 2x plus 3. And just get in the habit, don't factor if your leading term's negative. You could, but factor out the negative as a GCF before you factor the rest. It's going to be a good habit to get into. So I'm going to factor out the negative first, and I'm left with a positive x squared minus 2x minus 3. And then I'm going to focus on factoring the x squared minus 2x minus 3. Yes? Because I factored out the negative. The y-intercept's positive 3. Okay. So as we factor, we got a negative out in front, and we're going to start factoring everything inside here. We're looking for two numbers that multiply to negative 3 and add to negative 2. What are they? Negative 3 and 1. Okay, so we get x squared minus 3x minus, positive 1x minus 3. And as you factor, just keep it all in brackets, whatever you're doing, because you have that negative out in front. You don't want to mix that up. Minus, still working with the brackets here, x times x minus 3 plus 1 times x minus 3. And then you end up something like this. I put a negative 1 out front. It could just be a negative sign, doesn't matter. But that would be your factored form. From that, we can get our zeros. How many factors are there? 3. Negative 1 is a factor. X minus 3 is a factor, and x plus 1 is a factor. But when you solve by factoring, the only ones that are going to give you answers are your factors that have variables. So that negative 1 is not going to help us at all with coming up with our zeros. So I plug in 0 for y. And then set my x minus 3 equal to 0 and my x plus 1 equal to 0. And I get x is 3 and negative 1. So I have a 0 at 3, 0 and at negative 1, 0. These are called zeros because they're values, they're x values that you plug into the equation that give you 0 for an answer. But they're also called what? Roots, and they're also called X intercepts. Okay? So now we got plenty of info to graph. Go ahead and see if you can finish this. Your final answer will look like this. On the bottom of page 1 and the bottom of this page, you see other additional like questions about kind of reflection questions about the work that we did. When you do your homework, make sure you answer those too. So again, your homework is to complete pages 1, 2, and 3. We kind of did about half the work together, but you need to make sure everything else on those pages is finished and then submit that to Gradescope due Monday morning. Okay, I'll stop there. Peace out.